Alright, so today we're going to be talking about molar mass. And what molar mass is, it's the mass of 1 mole of a substance. So remember, a mole is 6.022 times 10 to the 23rd of something. Okay? And molar mass is the mass of that number. Okay? So it would be like taking, like for a dozen, right? If you took a dozen eggs and then you found the mass of them, that would be the mass of a dozen, right? We're talking about the mass of a mole. Okay, so the mass of 6.022 times 10 to the 23rd particles of something, all right? And what we actually found out is that mass is what's recorded on the periodic table, okay? So oxygen is 16.0 grams per mole. Sodium is 22.99 grams per mole. So if you guys look on your periodic table, the decimal mass, the average atomic mass, is actually the mass of 1 mole of a substance, okay? So we're going to figure out how we can determine what the molar mass is of different compounds. So all you have to do to find out the molar mass of different compounds is add up the molar masses of the elements. Okay. Alright, so what we're going to do is we're going to actually add up the mass of sodium and the mass of chlorine, and that's going to give us the molar mass of NaCl. So Na is 22.99, and then if you look on the periodic table, Cl, chlorine, will be 35.45 grams per mole. So all you're going to do is add them up, okay? That 22.99 plus that 35.45, add them up, and you get 58.44 grams per mole. And that's the molar mass of NaCl, of table salt, okay? So if you took out and massed out 58.44 grams of salt in your kitchen, it would be 1 mole of salt. All right? Let's find out the molar mass of water. This is going to be one you're going to see over and over again. So this one's really, really important, okay? So there are 2 hydrogens in this case, not just 1. So you're going to have to do hydrogen times 2 plus 1 oxygen, okay? So if you notice in my calculations, what I've got here is I've got this 2 times 1.01. This is the mass of hydrogen, okay? But there are 2 hydrogens, okay? So I have to make sure there are 2 of them, plus 16, and there's only 1 oxygen, okay? So you get 18.02 grams per mole as your molar mass of water. Alright, so now we're going to have to use this to bring it into stoichiometry. Alright, so here's a question. Yesterday I found a chunk of copper in the lab from the beginning of the year. That wouldn't happen, but let's pretend. Alright, so I used the balance to determine what the mass was. The mass was 500 grams of copper. So when you look at this, you want to start and you want to put your given over 1. You'll notice that I'm given 500 grams. That's going to be my given, okay? And I'm looking to find moles, okay? So you want to go from grams to moles. And the way we go from grams to moles is using our molar mass. Okay, so let's start with our given over 1. It's going to be 500 grams of copper over 1. So now we have to use our molar mass. All right, if we look on the periodic table, we should notice that copper is 63.5 grams for every mole. So you'll notice that 63.5 grams went in the denominator. That's so my grams of copper cancels out, and I'm left just with moles of copper. All right, so now I do the math out, 500 grams divided by 63.5, and I get 7.87 moles of copper. All right, so you can see how this molar mass from the periodic table gets inserted in as a new unit conversion. Okay, so every molar mass on the periodic table is going to be a new unit conversion. All right, let's try a second example. Okay, so for this one, we have to start by adding up our molar mass. So if you look, we've got Na, which is 22.99. We've got H, which is 1.01. C, which is 12.01. And then we've got oxygen, but we've got 3 of them. Okay, so we've got 3 times 16.0. All right, so we need to add all of those up to get our molar mass. So 22.99 plus 1.01 plus 12.01 plus 3 times 16, all right? And that's 84.01 grams per mole. Make sure you're writing down that unit, grams per mole, all right? We're going to use this information, this molar mass of baking soda, to help us find the moles of baking soda, so we're looking for moles of baking soda, in a 100-gram sample. So I start by putting my 100 grams over 1, okay? And then I'm going to use my molar mass, that 84.01 grams per mole. 84.01 is going to go on the bottom because I'm looking for moles. All right, I cancel out my units just like normal. So grams of NaHCO3, grams of baking soda, and I'm going to calculate it out to get 1.19 moles of NaHCO3 baking soda. All right. We're going to do one more example so you can see the difference between calculating using molar mass and calculating using Avogadro's number. Okay, Avogadro's number is that 6.022 times 10 to the 23rd. So this next question says how many moles, so it still asks for moles, but it gives you different information. It says how many moles is 3.34 times 10 to the 21st molecules. So something you're noticing is you're still going to moles, but you're trying to start with molecules. Okay, so start with your molecules over 1, and then what you need to do is you need to put your number of molecules that should cancel that out in the bottom. So remember that you have 6.022 times 10 to the 23rd particles in 1 mole. Okay, so that 6.022 times 10 to the 23rd particles, or molecules, is going to go on the denominator, and you have 1 mole on the top. You're going to do the math out. Don't forget to use your parentheses, order of operations in your calculator. And we should be getting 0.0055 moles of baking soda. So you'll notice the difference. The second one, we had to use our molar mass, and then the last question, we had to use our mole, okay, mole to particle. All right, so you're going to have two numbers. One's going to come from the brain, which is the 6.022 times 10 to the 23rd, and then the other one is going to come from the periodic table. You'll always be given a periodic table to use. All right, so we're going to be using a mole map in order to help us go between moles and mass and moles and particles and know which number to use and when, okay? So what we're going to do is we're going to have moles in the center, we're going to put mass on one side, and we're going to put particles on the other. It's important to remember that particles also means atoms, and it also means molecules. All right? So you need to make sure atoms and molecules are particles, and then mass is on the other side. So to go between moles and mass, you're going to use your molar mass, okay? And that's the unit of grams per mole. So this actually comes from the periodic table, okay? So you just have to use the periodic table to find this number. It'll always be there, okay? To go from moles to particles, we already did this, 6.022 times 10 to the 23rd particles per mole. All you have to do is remember this from your brain, okay? So one number comes from the periodic table, that's your molar mass. The other number comes from your brain, which is 6.022 times 10 to the 23rd particles per mole. I'm going to do one quick example that goes actually all the way through from mass to particles or particles to mass, because you're going to set these up, okay? So you can do multiple step problems, all right? So I put that molar map up at the top. I highly suggest you use that molar map when you are doing your own work, okay, so that you can help remember that, all right? So we've got a gold brick weighing 12,500 grams, okay, that's the mass. I want to know how many atoms are in the brick, okay? So we're going from mass to particles. We can't just go straight over, okay? What we've got to do is we need to go mass to moles, moles to particles, okay? So that's going to be our game plan. We start out with our given over 1, 12,500 grams over 1. Then we're going to use our molar mass of gold. AU is 196.96, okay? So we're going to use that. And we cancel out our units. So you guys can see we're canceling out our grams of gold, and we're left over with moles. So we're now in this stage right here. We've got our moles. Now we have to use Avogadro's number to go from moles to particles. So moles is on the top, and we're going to put 6.022 times 10 to the 23rd atoms on the bottom. Moles on the top, so moles has to go on the bottom. 6.022 times 10 to the 23rd atoms on the top. So you put that in your calculator, multiply 12,500 times 6.022 times 10 to the 23rd, and then you're going to divide by 196.96. And what do you get? 3.82 times 10 to the 25 gold atoms. All right, so that's a more challenging problem. That's a multiple step problem. We'll do some practice with these in school together. Awesome.